Okay, so today we're going to look at some example titration calculations. This is for Unit 4. So first off, we're going to write our reaction for this, whoops, plus, and then acetic acid. And we're going to get sodium acetate and water. Okay, and we have 0.02 liters of 0.25 molar, and then it says that we titrated that with 0.0232 liters of the acetic acid. Okay, now titration, the whole goal is to react them exactly. So the first thing that we know with titration is that we want to end up at the equivalence point, which is where both reactants are at 0 on there. Okay, in this one, we're just working with the acid and the base. So I'm just going to kind of squiggle out that we don't care about those. All right, so molarity times liters will get us our moles. So 0.02 times 0.25. And so I have 0.005 moles, which means my change is 0.005. These are 1 to 1, which means that change had to be 0.005, which means that's how much I had to start with. So now, once I have that, and this you'll see with these titrations problems, you've got your VCA, and then you follow that up usually with a molarity calculation. So I'm going to do that in a different tone. Okay, great. Sorry about that. Okay, so now I have the molarity is what I'm solving for of my acid, and I have 0.005 moles, and that is 0.0232 liters was the volume of that. So divide by 0.0232, and so I'm getting a molarity for my acid of 0.216. Okay. All right, so let's look at another one where it's not 1 to 1. So here, this one, let's write our reaction. And sodium phosphate and water. And I got a balance, setting 3, and we'll get 3 there. Okay, so I have 0.01 liters of 0.5 molarity, and I used 0.0232 liters. Right, so here again, it's a titration, so it's going to 0. Right now, it's not asking anything about the products. So here, it's going to be 0.005 and minus 0.005, which means the change in the phosphoric acid is a third of that because it's a 3 to 1 ratio. So that divided by 3 means this one is 0.00167. Okay, and again, it wants the molarity. So 0.00167 divided by 0.0232 liters, and that gives me a molarity of 0.0718. All right. The other type of problem that you'll have is one where you're finding the molar mass of the acid. Okay, so the key thing we're going to note here is that it's telling me it's a monoprotic acid. And monoprotic means that it has one hydrogen in it that can neutralize a hydroxide. And so that just means that when I write my reaction, and I'm just going to do this generic, that the acid to the sodium hydroxide is going to be a one-to-one relationship. We're just, right now, we don't care about the formulas, well, we don't know the formula. So we'll just write it just like that. And here I have 0.103 molarity, and it is 0.0225 liters. And the only thing I know about the acid is it's 0.523 grams. And any problem where it's asking for molar mass, the thing you want to remember is that, okay, I need grams of that substance and I need to know moles of that substance because I want to do grams divided by moles. So once again, it's titration, so we're going to 0. And here I have 0.103 times 0.0225. So 0.00232, that's my moles of sodium hydroxide. All right, so that's my change, which means the acid is here, like that. So there's my moles, 0.00232 moles, and then 0.523 is my grams, 523 divided by 0.00232. So I get a molar mass of 225.4, and that's grams per mole for the molar mass of the acid.